بسم الله الرحمن الرحيم. الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. These are some exercises about section 2.3. Well, limit of f of x is given and it is equal to 4. Limit g of x is equal to -2 and limit h of x is 0. The question: find the limits that exists. If the limit does not exist, explain why. Now find this limit. Well, we have seen that the limit can go inside parentheses. So we can write this limit like this. And now we have limit g of x when x approaches 2. It's given in the question. So the answer is -8. Also, we can distribute the limit as we have seen from the properties of the limits. So we can write it limit g of x times limit h of x over limit f of x, all when x approaches 2. Limit g is given, it is -2. Limit h is given 0. And limit f of x is 4. So the answer is 0. Now the graphs of f and g are given. Use them to evaluate each limit if it exists. Again, we can use the limit properties to write this limit as limit of f of x times limit of g of x when x approaches -1. And now we look to the graph x approaching -1. You go to -1. This is -1. Approach -1 from the right. Let x approaches -1 from the right. And look to the function. The function is coming to 1. Approach -1 from the left. If x approaches -1 from the left, look to the function. It's going up and it's approaching also 1. So limit f of x when x approaches -1 is 1. What about g of x? Well, this is -1. When x approaches -1 from the right, now while you are here, the function is here. If you come closer to -1, the function would be here, then here, then here. So it's going like this. And it's approaching this point, which is 1, 2. If x approaches -1 from the left, also the function would be here, so it will go up to 2. So limit of g of x when x approaches -1 is just 2. And the answer would be 2. All right. Now another question. Limit x squared times f of x. Well, using the limit properties, this is the limit of x squared when x approaches 2 times limit of f of x when x approaches 2. Well, how to find limit x squared when x approaches 2? We replace x by 2, so 2 squared is 4. While limit f of x, we find it from the graph. X approaches 2. 1, 2, this is 2. Let x approach 2 from the right and look to the function. Now the function was here, then here, then here. It's coming down to -1. Okay, if x approaches 2 from the left, while you are here, the function is here, then it becomes here, and it's approaching also -1. So as x approaches 2, the function f of x is approaching -1. So the answer is -4. Here, f of -1. Well, this is -1. And to find f of -1, I go up or down until I reach the graph. This is an open circle, a hole. So here, this is f of -1. 1, 2, this is 3. Y here is 3. So f of -1 is 3. What about the limit of g of x when x approaches -1? This is -1. If x approaches -1 from the right, well, the function is approaching 2. And approaching -1 from the left, also the function is approaching 2. And we have seen this here. So it's 2 and 3 plus 2 is just 5. Evaluate this limit. To evaluate this limit, I just replace t by -1. You can write it if you like. You can let limit comes inside the parentheses and then 2 times limit t to the power 5 and so on. But at the end, as we have seen, if it's a fractional, if it's a rational function or polynomial, we can just replace t by -1. So 2 times -1 to the power 5 minus -1 to the power 4 over 5 times -1 to the power 2 plus 4 all to the power 3. -1 to the power 5 is -1, so this would be -2. -1 to the power 4 is +1, so this would be -1. -1 to the power 2 is +1 times 5 plus 4 all to the power 3. So -3 over 9 all to the power 3. If you divide by 3, it would be -1 over 3 all to the power 3. And then the answer is -1 over 27. Evaluate the limit if it exists. If we first replace t by 4, we will get 16 minus 8 minus 8, that's 0 over 0. Once you have 0 over 0, try to use algebraic operation to deal with this fraction. 0 over 0 means that here we have t minus 4. That's why when we replace t by 4, we got 4 minus 4. And we must have t minus 4 also in the numerator, because also it was 0 when we replaced t by 0. So try to factor here the numerator. This is a quadratic equation. You can factor easily. T squared, you write it t times t. And you search for two numbers. Their product is -8 and their sum is -2. So -4 and +2 will give you -8 and their sum is -2. And you notice t minus 4 appears here. So now you can cancel t minus 4 with t minus 4. And now you can replace t by 4 to find the limit. So the limit would be 4 plus 2, which is 6. Here, if you replace x by 2, you will get 4 plus 10 plus 4, that's 18, over 2 minus 2, which is 0. So you get 18 over 0. Well, 18 over 0 is not like 0 over 0. 0 over 0, you can work with it and get a limit. But 18 over 0, that's it. The answer is a number over 0. So it's either infinity or negative infinity. So we need to determine what is this limit. To find out, I will find the limit when x approaches 2 from the right. Now, if you replace, even if you are finding the limit from the right, you replace x by 2. But if you replace x by 2, we will find 18 over 0. So we know that this limit is positive or negative infinity. And we need to determine out whether it's positive or negative infinity. So replace x by 2.1. Why are we replacing x by 2.1 here? To find out whether this quantity would be positive or negative, and then to determine whether the limit is positive infinity or negative infinity. This is always, in this case, the numerator is positive and 2.1 minus 2 is positive. So the answer is positive. So the limit would be infinity. While the limit when t approaches 2 from the left of x squared plus 5x plus 4 over x minus 2, if we replace t by 2, which should be the case, we get 18 over 0. So 18 over 0 will give you either positive infinity or negative infinity. So how to find out? I replace t now by a number less than 2 because we are approaching 2 from the left. So 1.9, for example, the numerator would be positive, the denominator would be negative. So this quantity will go to negative infinity as t approaches 2 from the left. Now, since from the right, the limit is infinity, from the left, the limit is negative infinity, so the limit of this quantity in general would be does not exist because the limit from the right is not equal to the limit from the left. If you replace x by negative infinity, you will get 0 here and 0 here. Okay, because 50 and this is minus 50, 0 over 0. Well, 0 over 0, you can think of factoring or doing any algebraic operation to solve the problem because it has a solution. There is a limit when it is 0 over 0, not like a number over 0. What can we do? Let us try to factor. This is x squared minus 25. This is difference of two squares. You can factor it into x minus 5 times x plus 5. Using the formula, u squared minus v squared equals u minus v times u plus v. While this is a trinomial, so you factor as usual. If you want, you got 0 over 0, so x plus 5 should be in the denominator and it should be also in the numerator. If we are sure that we have x plus 5 here, then we can factor. This is 2x squared. So usually 2x squared is factored into a term here and a term here. So for sure this term now would be 2x. Now 2x times x would be 2x squared. And also negative 5, we factor negative 5 into two numbers, one here and one here. So this is 5, so this should be negative 5. Negative 1, sorry. So negative 1 times 5 is negative 5. And now you can make sure that the inner term, 10x, the outer negative x, 10 minus 1 is 9. So our factoring is correct. X plus 5 will cancel with x plus 5, and we can replace x by negative 5 now. 2 times minus 5 is negative 10 minus 1, that's negative 11. And minus 5 times minus 5 minus 5 would be negative 10. So the answer is 11 over 10. Here we have difference of two cubes. If you replace t by 3, you will find 0 over 0. So to factor, you should know how to factor difference of two cubes. This formula enables you to factor difference of two squares. But difference of two cubes can be factored also using this formula. We take u minus v, the cube root of the first term, the cube root of the second term, then times. Now here we have three terms and you find it from here. You square the first term, you change the sign, you multiply them without 2, without multiplying by 2, and then you add the second term squared. If it is plus addition of sum of two cubes, this would be plus similarly. And here, when you change the sign in the second term, you will get minus, but this will remain plus. So let us use this formula to factor this. So cube root of t cube is t, cube root of 27 is 3, and now t square, change the sign, multiply them, and square the second term over. This is a difference of two squares. So u minus v, square root of the first term t, square root of the second term, which is 3, and then write it again with a different sign. So t plus 3. These two will be cancelled. And now when you replace t by 3, you will have 9 plus 9 plus 9. So that's 27 over 3 plus 3, that's 6. Divide by 3, this is 9 over 2. That would be the limit. Here, if you replace u by -1, you get again 0 over 0. So you will think of factoring. U plus 1 is already factored, but here you have sum of two cubes. So you use the same formula, this one, okay? So you take the cube root of u cube, which is u, plus the cube root of 1, which is 1, and now you square the first term, you change the sign, multiply the two terms, and square the second term. U plus 1 will be cancelled with u plus 1. I'll have 1 here in the numerator. And if you replace u by -1, I have 1 plus 1 plus 1. So it's 1 over 3. If you replace x by 2 here, you get 0 over 0. 4 square root of 4, 2 minus 2 is 0. We have a square root minus a number. In this case, we multiply by the conjugate of this. The conjugate is x plus 2 plus 2. Okay, we need to use this formula. So if we have u minus v, the conjugate is u plus v. When we multiply them, we will get u square minus v square. So we will square the first term, which is this one, and square the second term. And when we square the square root, we will get rid of it. So we have limit when x approaches 2, multiply the two terms in the numerators, and just leave them like this, because we are expecting that 2 minus x would be cancelled. Now, if you multiply these two, u minus v times u plus v, you get u square, which is x plus 2, minus v square, which is 4. So you will have, if you want, you can take negative sign from this, these two terms. So you will have, if you take negative sign from negative x, it would be x. If you take negative sign from 2, it would be, instead of positive, it would be -2 times x plus 2 plus 2 over x, and 2 minus 4 is -2. So why I took minus as a common factor? Because now x minus 2 is cancelled with x minus 2. In general, if you have 2 minus x over x minus 2, you know if you multiply the numerator by negative sign, you will get the denominator. So you can divide them and get -1. So immediately you can cancel 2 minus x with x minus 2 and put a -1. And now you can replace x by 2. So there is a negative sign, and 2 plus 2, 4. Square root of 4 is 2 plus 2, 4, and that would be the answer. Here 1 over 0 not defined, 1 over 0 not defined. So I will try to add these two terms, or I can also try to write it like this. I have 1 over t, and I can take t here as a common factor. And now I have 1 over t. I can take it as a common factor from the two terms. So I'll have 1 minus 1 over t plus 1. And to add or subtract two fractions, you use this formula. You multiply the two denominators, and then you multiply a times d minus b times c. So we will have the limit when t approaches 0 of 1 over t times. Here this is 1 over 1. So if you multiply the denominator 1 times t plus 1, you get t plus 1. And then t plus 1 times 1, which is t plus 1, minus 1 times 1, which is 1. Now 1 cancels with 1. And then t cancels with t. Okay, after you cancel 1 with 1, you cancel t with t. And then you will have 1 in the numerator. And if you replace t by 0, you get 0 plus 1, which is 1. And the limit would be 1. If you want, if this is difficult for you and you want immediately to use this formula to subtract these two terms, then you multiply the denominators, and t squared plus t times 1 is t squared plus t, and 1 times t would be like this. Now t cancels with t, and you have t squared over t, so it would be 1t in the numerator, and this will be cancelled with 1 of here. And now I have t squared plus t. But notice that I can take t as a common factor. So now t cancels with t, and I have 1 in the numerator, and replace t by 0. I have 1 over 1, and the answer is also 1. Here, evaluate limit g of x. G of x lies between two functions. So we remember the squeeze theorem here, and we try to find limit this function 2 of x when x approaches 1. Well, we replace x by 1 and the limit is 2. What about limit the other function? X to the power 4 minus x squared plus 2 when x approaches 1. It would be 1 minus 1, that's 0, plus 2, so it would be 2. So both functions have the same limit when x approaches 2. So by squeeze theorem, we will have limit g of x, the one in between them, the one between these two functions, when x equals 1, would be also equal, would be 2. Find the limit if it exists. Well, this is an absolute value. You need to write the absolute value again. You need to understand that absolute value has two branches. It's a piecewise function. Either it becomes x plus 4 or negative x minus 4. It would become x plus 4 if x plus 4 is greater than 0, greater than or equal. And here x plus 4 is less than 0. But if you solve this inequality, this means if x is greater than or equal to negative 4, and here less than negative 4, you take negative 4 to the, you take 4 to the other side. Okay, so forget about this now, and we have this new condition. Now to find this limit, I'll find the limit from the right and from the left because I have a piecewise function. So when I find the limit from the right, I take a number greater than negative 4. So the definition of the absolute value would be x plus 4. Notice that 2x plus 8, if you take 2 as a common factor, would be like this. And now you can cancel x plus 4 with x plus 4, and the limit would be 1 over 2. You remember the limit of a constant is just a constant. Let us find the limit when x approaches negative 4 from the left. Well, in this case, we will take numbers less than negative 4. So the definition would be negative x minus 4, or you can take the negative sign as a common factor, because I need to cancel these two, and the limit would be negative 1 over 2. The limit from the right is not equal to the limit from the left, so this limit does not exist. Find C so that the limit of this function when t approaches 2 exists. Well, the limit will exist if the limit of bt when t approaches 2 from the right equals to the limit of bt when t approaches 2 from the left. So let us find this first. T approaches 2 from the right, so we should use numbers greater than 2. Greater than 2, this would be the definition of b of t. So I will use it. And now how to find the limit? We replace t by 2. So this is the limit from the right. To find the limit from the left of b of t, we will use numbers less than 2. Less than 2 means the definition of the function is 4 minus half t. Now we replace t by 2 to get 4 minus half times 2 is 1, so this is 3. Now if we want the limit of b of t to exist, then the limit from the right should equal to the limit from the left. So square root of 2 plus c should be equal to 3. How to solve this equation and find the value of c? We raise both sides of equation to the power 2. So 2 plus c would be equal to 9. Then c is 9 minus 2, which is 7. So this is the value of c. Thank you very much. I hope you enjoyed listening to these exercises. Please try to